Hello everyone, welcome back to the channel. If you are starting your journey in electronics, then you have probably heard the word diode many times. But have you ever wondered what exactly a diode is, how it's work, and why almost every electronic circuit uses one? In today's video, we were going to learn everything about diodes in a very simple and beginner friendly way. So, without wasting any time, let's get started. So, first of all, what is a diode? A diode is two-terminal semiconductor device and that allows electrical current to flow in only one direction while blocking it in opposite direction. That's why a diode is often called a one-way valve of electricity. Every diode has two terminals, anode and cathode. Positive terminal is anode and negative terminal is cathode. Current flows from the anode to the cathode when the diode is a forward bias. This is the circuit symbol of diode and this is what a real diode looks like. Now you may ask, if you already have wires to carry current, then why do you even need the diode? The answer is very simple. Many electronic circuits need current to flow in only one direction. If current started flowing backward, it can damage components or make the circuit work incorrectly. So a diode solved this problem by controlling the direction of current. Now let's understand the working principle. A diode has two operating conditions. The first one is forward bias. When the positive terminal of the battery is connected to the anode and the negative terminal is connected to the cathode, the diode turns on and current flows. This is called forward bias. And the second condition is reverse bias. When we reverse the battery connection, the diode blocks the current. So a diode behaves like a automatic one-way switch. One important thing to remember is that a diode is not a perfect conductor. When current flows through a silicon diode, there is a small voltage drop of approximately 0.7 volt, and for germanium diodes, this voltage drop is around 0.3 volts. There are different types of diode and each one has a specific purpose. A rectifier diode is mainly used for converting AC into DC. A Zener diode is used for voltage regulation and LED produce light. A Schottky diode provides fast switching with low voltage drop and a photodiode detects light. We will discuss each of these diodes in details in upcoming videos. Now comes the most important part, the application of a diode. The first application is preventing reverse current. A diode allows current to move in only one direction. If current tries to flow backward, the diode blocks it. This protects battery and many electronic circuits from unwanted reverse current. The second application is reverse polarity protection. Sometimes we accidentally connect a battery in the wrong direction. Without protection, this mistake can damage expensive electronics components. A diode prevents this reverse current and keeps the circuit safe. The next application is rectification. The electricity come from our wall socket is AC. However, the most electronics device require DC power. Rectifier diodes convert AC into DC, which is why every charger and power supply contains a diode. Another important application is voltage regulation. Here we use a special diode called the Zener diode. It maintains a constant output voltage even when the input voltage changes. That's why it's commonly used in power supply and reference circuits. Next, LED. One of the most popular types of the diode is the LED. LED stands for light emitting diodes. Whenever current flows through an LED in the forward direction, it emits light. LED are used in bulbs, TV display, inductors, traffic lights, and many more electronics products. Diodes are also widely used in communication systems. They help recover information from radio frequency signals. For example, in AM radio receiver, diode extract the audio signal from the radio waves. Next, electronic switching. Diode can also act as electronic switches. Depending on the direction of the applied voltage, they either allow current to pass or block it. Because of this property, diodes are used in digital electronics and switching circuits. Next, protect components from voltage spike. Finally, diodes protect electronics components from voltage spike. When motor, relays, or coil are switched off, they generate high voltage pulse. A flyback diode safely absorbs their spikes and protects sensitive components like microcontroller and integrated circuits. So, what are the advantage of using diodes? They are inexpensive, reliable, small in size, consume very little power, and provide excellent protection for electronic circuit. So today we learned what a diode is. If you found this video helpful, don't forget to like, share, and subscribe.